Okay, I will do the odds and then you do the evens. Number one, we want to change it to scientific notation. So we're going to write down the first digit, a decimal point, and then the other significant digits. So we have a 2, 5, and a 3. 2, 5, and 3. And then it's times 10. And this is a large number, so it's going to be a positive exponent. Here's the decimal point. I want to move it over here. I want to move it right there. So how many spaces from there to there? That's 3, 6, 7. So our exponent is 7. On number 3, change the decimal to a fraction. So what you do is just say it and then write it. This is 36 hundredths. So it's 36 over 100. And that can be reduced. Let's see, 2 goes into 36. Actually, how about 4? 4 will go into 36 9 times. And 4 goes into 100 25 times. So 4 is a better one to reduce by. And can this be reduced? 3 goes in there, 3 does not go in there, so that is it. So we change a decimal to a fraction. Number 5, we simplify this. So remember, it's PEMDAS. We always do the exponents before any multiplying. 2 to the third power is 2 times 2, 2 times 2 times 2. That's 4 times 2 is 8. And this is 3. So 3 times 8 is 24. Number 7, we always work inside the parentheses first. 12 divided by 2. 12 divided by 2 is simply 6. I'm going to put a 6 up here. And so I have 3 plus 5 minus 6 times 2, times 3. So now I do the times. I did the parentheses, 6. 6 times 3 is 18. I'm trying to save room here, is why I'm writing like this. So all of this right here is 18. So I have 3 plus 5 minus 18. 3 plus 5 is 8. So now I have 8 minus 18. 8 minus 18 is, they're different signs, so I subtract. 18 take away 8 is 10, and there's more negative. Okay, now let's go to the top of the paper. Number 9. Okay, we want to simplify this expression. Remember, the absolute value means how far away is it from 0. So let's see, I have 12 minus 5. 12 minus 5 is 7. So I have the absolute value of 7 here, minus the absolute value of 3 minus 7. They're different signs, so it's subtract them. 7 take away 3 is 4, and there's more negative, so it's negative 4. So now I have 7 minus the absolute value of negative 4. Let's see, negative 4 is 4 spaces from 0. And 7 is 7 spaces from 0. So I have 7 minus 4. 7 take away 4 is simply 3. Okay, absolute value means how far away it is from 0. Negative 4 is 4 spaces from 0. Okay, on number 11, remember you want the variable by itself. So I need to do the opposite. The opposite of times, this is negative 3 times, is divide. So I'll divide by negative 3. Divide by negative 3. That leaves me with x. Hey, wait a minute. If I divide by a negative, I need to switch the arrow. And 3 goes into 18, 6, and there's 1 negative. Number 13, we need to solve for x, and then we can graph it. So let's see, I want to get rid of plus 4. So I subtract 4. That's gone. I have x. Hey, do I need to change the arrow if I subtracted 4? No. That's only if you multiply or divide by a negative. I just subtracted. 15 take away 4 is 11. So let's see, 11, that would be over here on this side of 0. And let's see, I have a bar. So it's equal. That means it's going to be a closed circle. And you shade the direction of the arrow. It's going to the right, so I shade to the right. This is all the answers. All the answers are numbers greater than 11. And all these numbers here are greater than 11. These are all the solutions. Number 15, determine the missing exponent. The missing exponent right here. Let's see, I have 8 and minus 13. Remember, I put those together. I just simply add them together. 8 and negative 13. It's simply 8 and negative 13, or 8 minus 13. 8 minus 13 is negative. See, 13 take away 8 is 5. So negative 5, that's the exponent that goes up there. Remember, you simply add the exponents. Okay, go ahead and turn your paper over. Okay, number 17, we're supposed to simplify this expression. You know what, I'll kind of do it the long ways here. 21 is 7 times 3. X squared is 2x's. Y to the 4th, that's 4y's. This is the long way. 7, I have 1x, and I have 2y's on the bottom. So on the top, 2x's, 4y's. On the bottom, 1x and 2y's. So now I can reduce. So let's see, 7 goes into 7. That leaves us with 1. X goes into x once. We have another pair of y's. Another pair of y's. Y goes into y once. So what are we left with? We're left with just a 3, 1x, and 2y's. And they are all, oops, I can just say y squared. I don't need to write y squared. So basically we have 3xy squared. And hopefully you could see that without me having to write that all out, factor it all out. But if you cannot see it, if you cannot do it by observing it, looking at it mentally, then you need to go ahead and factor it out. Okay, on number 19, all we're doing is we're multiplying exponents here. And if you don't see an exponent, then it must be the invisible 1. So there's a 1 right there. And there's a 1 above the b. So basically this is 3. 3 times 1 is 3 to the 3rd power. And a to the 3 times 5 is 15 power. And the b to the 3 times 1, that's 3. We're just multiplying the exponents. The thing is though, when you have a number to the exponent to a certain power, you need to go ahead and simplify that. So 3 to the 3rd power is 3 times 3 times 3. Well, that's 2 3's make 9. 9 times 3 is 27. So now I have 27, a to the 15th, b cubed. Okay, on 21, 3 to the negative 3 power. Whenever you have a negative exponent, remember the key word? Location, location, location. It's in the wrong location. It should be down below. Okay, this whole thing should be down below and not up above. So really what we have is 3 to the positive 3, but down below. Not 3 to the negative 3 up above, 3 to the positive 3 down below. What's up here on top? Just a 1, the invisible 1. And 3 to the 3rd power, oops, excuse me. That's 3 times 3 times 3. So there's your answer.